Hey everyone, welcome to the first video of this channel. In this video I am going to show you how to perform image augmentation using convolutional neural networks. Basically, image augmentation is a technique used to artificially expand the size of your dataset by creating modified version of existing images. We apply transformations like flipping, rotation, zooming, shifting and so on. This helps our model generates better and prevents overfitting, especially when the dataset is small. From this video, our goal is to expand our dataset from 300 images to around 750 images using augmentation techniques. Once you learn this process, you will be able to augment any kind of image dataset in a similar way, whether it's animals, food, fashion, or anything else. So let's start the video. Okay, so to begin with, I have collected a dataset from Kaggle. This dataset contains 300 images divided into 5 categories with 60 images in each category. Let me check every folder. Okay, so everything is fine. Now I will zip this folder and upload it to Google Drive so we can easily access it from Google Colab. Now I am going to zip folder is done. Now I am going to Google Drive and here I am making a folder which first I am rename the folder. So images will be our folder's name, and in this images folder I will upload the image classification.zip file. It will take some time. Okay, now I will go to Google Colab. Okay, I am making it from scratch so that you can understand easily. Now in my new Colab file, it will take some time. So after opening it, I will just rename it so that you also can remember which file it is. So I rename the image classification.ipy3. Now let's start by connecting Google Colab with our Google Drive. So we do that with this line. So let me write the line for you. Okay. Okay, I have written the line. Okay, now I am running this code. So after running this, Colab will ask for your permission to access Google Drive. It will take some time. Just click the link, login. Once it mounted successfully, we will be able to read and write files directly from Drive. It is super helpful for loading datasets and saving models later on. I think we have mounted our drive. Right now, let's unzip our dataset. I already have a small piece of code ready for that. You just need to change the file path to where your file is located. This will extract the dataset into a folder. Let me change the path. Just images here. Okay. Everything I am showing here is completely from scratch, so even if you are new to this, you can easily follow along. Now it's ready for to use in our CNN model. Okay, all are fine. Now next step. So in the next step, let's import the necessary libraries we will be using throughout our project. So we begin with NumPy, which is crucial for handling arrays and numerical operations. Next, we import TensorFlow for building and training our neural network as well as Keras, which is part of TensorFlow and simplifies working with models. We also use OpenCV to process images. It's a powerful library for image manipulation. Wes helps us manage file paths and directories, while Random will assist in shuffling and randomizing data. Math is great for performing submatricial operation. And lastly, matplotlib.pyplot will allow us to plot images and graphs to visualize our progress. Okay, so here are the imports. Let's run it. Uh, yeah, we have made a mistake. Let's change it and again run it. I think all will be fine now. Yeah. These libraries will set the foundation for the rest of our code. Now we want to check how many images we have in each category within our dataset. So here how we do it. We define first we need to define the dataset path, which points to our folder where the images are stored. For this, we need to write our code from the path where our images folder is created. Image augmentation. Image augmentation. Sorry, image classification. Then we create an empty dictionary. For this, we need to write number of images equal to an empty array to store the count of images for each category. Now we use a for loop to go through each subdirectory in the dataset. For this, we need to write for dir in os.listdir dataset. This will give us the number of images in each category. After the loop, we will have a dictionary where each key is the category name and the value is the number of images in that category. Let me finish the line. Okay. Oh, I think we made another mistake, so let me check it. And yeah, I have found it. I need to check it again. Okay. Okay, all done. So right now that we have the number of images in each category, let's display it so we can easily see the image distribution across the different categories. So by simply running number of images.items, you will see the categories and their corresponding image counts displayed in the output. So here it is. Next, we want to create a new dictionary directory where, where we will store the augmented dataset. First, we define the original dataset directory path, which is where our original images are located. So I am writing the code. Content drive, my drive. So here we have already written our path. So just copy and paste the code. Then we need to define the base directory where the augmented images will be stored. For this, we need to write base dir and just paste the path you previously copied and just change the location and change the folder name. Okay, so I name the folder augmented dataset. Let's change it, not augmented, it will be augment dataset. Okay, to make sure this directory doesn't already exist, we use os.mkdir in the bracket base dir to create the folder if it doesn't exist. This will be our storage location for the augmented images. So go to the drive, let's refresh it, again refresh it. You can see augment dataset folder is created here, but the folder is empty. For this we need to make 5 categories of folder which we have in image classification. So we need to create this folder. For this we need to create individual subcategories for each of the categories where our augmented images will be stored. These categories are you all see. So let's start by creating the battery category directory. For this I am writing the code here. Battery. We then create this directory using os.mkdir in the bracket battery dir. Okay. Similarly, we need to do this for each of the categories. So I have already copied the code. So let me paste. Okay. So all codes are written here. So go to the my drive and augment dataset. Let's refresh it. You can see all 5 folders are created. Now we need in this part we will be generating augmented images using the Albumentations library. So I have copied the code which this code provides a wide range of powerful image augmentation techniques to help enhance our dataset. First, we need to define the path to the original images. Next, we define augmentations profile using Albumentations Library. Some of the augmentations will use vertical flip, random 90-degree rotation, horizontal flip, transpose, grid distortion. We set a loop that will iterate 100 times to generate 150 times to generate 150 augmented images. At first, we need to change the path. So from the first one is our original dataset path, and the second one is our augmented dataset path. So first I am changing to battery. We need to do the similar process for every folder. So now I will change battery to clocks and run it. We need to do it for each category, and then our dataset will turn into 300 to 750 images. By this way you can augment your images. After doing all these things, I will show you our total images number by doing the same way. Now paper, let's run it. Okay, now another category. Okay, now the last category is shoes. So let me write shoes. Okay, let's run the code. Okay, all done. Now in this section of the code, we are examining the augmented dataset to check how many images we have in each category after performing the augmentation. So the same process. So we have written the code previously. Just copy the code and paste it and just change the path. So we need just to change our folder name. So our folder name will be augment dataset. So let's write augment dataset. Okay, let's run it. Now the last part, we want to see the number of augmented images. So here it is. So for this video, we have our goal is to expand our dataset from 300 images to 750 images, which is done. So you can, I hope you learned it. Thank you everyone. Keep watching DIRIVerse channel. We will see you again in another video. Thank you everyone.